The mystery of Earth's most dangerous weather patterns. Ever wondered what lurks behind a seemingly calm sky? Earth's weather can be beautiful, but it also hides some truly dangerous secrets. Let's uncover the mystery of our planet's most destructive weather patterns. Hurricanes are nature's giants, massive rotating storms that feed off the warmth of the ocean. They are powerful engines of destruction. These storms draw energy from warm ocean waters, growing in size and intensity as they move. We're getting better at predicting where hurricanes will go. Advanced tracking technology helps us map their paths with increasing accuracy. But predicting how strong they'll become remains a significant challenge. One of the biggest hurdles is predicting rapid intensification. This is when a hurricane's strength increases dramatically in a short period. It can catch communities off guard and lead to devastating consequences. Several factors influence a hurricane's intensity. Ocean temperature anomalies, or unusually warm patches of water, fuel their growth. Atmospheric wind shear, which is the change in wind speed and direction with altitude, can either strengthen or weaken them. Interaction with landmasses also plays a crucial role. Unexpected changes in intensity can have devastating consequences. Communities may underestimate the threat and fail to prepare adequately. This can lead to widespread damage and loss of life. It's important to remember that hurricanes go by different names depending on their location. In the Western Pacific, they're called typhoons, and in the Indian Ocean, they're known as cyclones. Regardless of the name, they are all powerful and dangerous storms. Tornadoes pose a significant threat, especially in regions like Tornado Alley in the United States. These violently rotating columns of air can appear suddenly and cause immense destruction. They are a force of nature to be reckoned with. A tornado is defined as a violently rotating column of air extending from a thunderstorm to the ground. Their power is concentrated in a small area, making them incredibly destructive. They can level homes and toss vehicles like toys. Predicting tornadoes with precision is incredibly difficult. They form quickly and dissipate just as fast. This makes it challenging to issue timely warnings and protect communities. Doppler radar is a crucial tool for detecting supercell thunderstorms. These are the types of storms that often produce tornadoes. The radar can detect the rotation within the storm, indicating the potential for a tornado to form. Even with advanced radar technology, pinpointing the exact location and timing of a tornado touchdown remains a challenge. The conditions that lead to tornado formation are complex and can change rapidly. This makes it difficult to provide precise warnings. Several factors influence tornado formation. Atmospheric instability, which is when warm, moist air is trapped beneath cooler, drier air, creates the potential for strong updrafts. Wind shear, the change in wind speed and direction with altitude, can cause the updraft to rotate. Moisture content in the atmosphere also plays a crucial role. Flash floods are triggered by slow-moving thunderstorms or torrential rainfall. They are a sudden and dangerous surge of water that can overwhelm communities in minutes. Their rapid onset makes them particularly deadly. The rapid onset and localized nature of flash floods make them difficult to anticipate. They can occur in areas that haven't experienced heavy rainfall themselves. This makes it challenging to issue timely warnings and protect communities. Communities are often caught unprepared for flash floods. The speed and intensity of the water can overwhelm infrastructure and homes. This can lead to widespread damage and loss of life. Several factors exacerbate the risk of flash floods. Soil saturation, when the ground is already soaked from previous rainfall, prevents water from being absorbed. Topography, such as steep slopes and narrow valleys, can channel water and increase its velocity. Impervious surfaces, like concrete and asphalt, prevent water from soaking into the ground. Climate change is contributing to more extreme rainfall events. Warmer temperatures lead to increased evaporation, which means more moisture in the atmosphere. This can result in heavier rainfall and a greater risk of flash floods. Flash floods are increasing in frequency and intensity worldwide. As the climate continues to change, we can expect to see more of these devastating events. It's crucial to be aware of the risks and take steps to protect yourself and your community. Beyond hurricanes, tornadoes, and flash floods, other weather patterns pose significant threats. These include extreme heat waves, prolonged droughts, and severe blizzards. Each of these can have devastating consequences for communities and ecosystems. Extreme heat waves can lead to heat stroke and other heat-related illnesses. Prolonged exposure to high temperatures can overwhelm the body's ability to regulate its temperature. This can be particularly dangerous for vulnerable populations, such as the elderly and those with chronic health conditions. Prolonged droughts have devastating impacts on agriculture and water resources. They can lead to crop failures, livestock losses, and water shortages. This can result in famine and displacement, particularly in regions that rely heavily on agriculture. Severe blizzards bring heavy snowfall and strong winds. They can cripple transportation and infrastructure, making it difficult to travel and access essential services. Blizzards can isolate communities and endanger lives, especially for those who are unprepared. The mystery of Earth's most dangerous weather patterns lies in the complex interactions between atmospheric and oceanic processes. Understanding these interactions is crucial for improving our ability to predict and prepare for these events. Scientists are working tirelessly to unravel these mysteries. Scientists are constantly improving forecasting models with sophisticated data. They use advanced technology, such as satellites and supercomputers, to gather and analyze vast amounts of data. This helps them to better understand the complex processes that drive these weather patterns. Understanding the role of climate change is critical for mitigation. By reducing greenhouse gas emissions, we can help to slow the rate of climate change and reduce the risk of extreme weather events. This requires a global effort and a commitment to sustainable practices. Now that you're aware of these dangerous weather patterns, what can you do? Stay informed about weather forecasts in your area. Develop a plan for how to respond to different types of weather emergencies. Support policies that address climate change. Together, we can build more resilient communities and protect ourselves from the mystery of Earth's most dangerous weather.